2011. We're on text page 194 and Blue Notebook page 315. Today we're going to go through lesson 4.6, and we're going to review at the same time because we have our test coming up on Wednesday. This is a recap of grade 9 ideas right here. These are just your exponent rules. So when you have the same base, so we have x and x, could be any numbers, 5 and 5, negative 12, 12, whatever you like. And they have exponents, and you're multiplying them. So for instance, this base is the same. The first exponent is a, and the other exponent is b. When you're multiplying numbers with the same base, and they both have exponents, just add the exponents. One way to show that is, for instance, let's use the number 5 times 5. Now we all know that what's that going to equal? 25. Another way we could have proven that is, what is the exponent technically over this 5? 1 and 1. The bases are the same. We add the exponents. What is 1 plus 1? So 5 to the power of 2 equals 25. That's the idea of the first one. The same thing is going to go with the other ones. If we have bases that are the same, and exponents are divided by each other, so a base and exponent divided by same base with a different exponent or the same one. All we have to do is put the base down and subtract our two exponents. Remember, like I said, this is a recap for grade 9. So that idea would look like this maybe. 5 to the power of 2 above 5 to the power of 1. That's really just 5 to subtract 1, 5 to the power of 1. And we're going to prove this stuff after. And finally, we have a base with the exponent to another exponent. All we have to do is multiply those exponents. So use the same numbers. 5, 2, actually we'll use 3 instead. Equal to 5, 2 times 3, which means this would be 5 to the power of 6. So that's all recap. Today what we're going to be going over is negative exponents and the power of 0. So first off, we'll touch on the power of 0. Power of 0. It's a pretty easy concept. I'm going to kind of just show you some proof to it. Yeah. I'm going to show you some proof to it. So first off, I'm going to keep using the base 5 just because I like that number. To the power of 0. Does anyone know what's going to equal? 1. That's simple. If I have pi to the power of 0, what will that equal? Infinity to the power of 0? 1. Actually, I don't know if that one's true. I got to check that one. But anyway, the idea is anything to the power of 0 is just 1. Actually, that is true. So I'm going to show you the proof to this. We'll use division. We'll use division to prove it. So let's say I have 5 to the power of 2 over 5 to the power of 2. Now technically, that says 5 by 5. Whoa, that is not a 5. Got other numbers in my head. Divided by 5 times 5. What does that equal? Well, what's 5 times 5? 25. Divided by 25. And what does that equal? 1. Right. That's our proof. So really, if you looked at this, by our rules we had before, all we had to do is take the two exponents, subtract them, and we know 5 to the power of 0 is 1. Right? This is like a shortcut to doing it. This is the proof. I don't know. Do you guys have any questions about that? I feel 0 is very, very straightforward. Just remember that. Anything to the power of 0 is equal to 1. It does not matter what the base is. Okay, so power of 0, you guys don't have a problem with it. We're going to do negative exponents. So, once again, I'm going to show you a rule. The power of negative 2. Okay? This says 5 to the power of negative 2. Now, first off, how can I write 5 as a fraction? Does anyone know? 5 over 1. Okay? Any whole number as a fraction is just that number over 1. So I'm going to rewrite this to say 5 over 1 to negative 2. Now I want to get rid of that negative. Say I want all of my answers to have positive exponents. I just have to flip the fraction, the reciprocal of that fraction. So I take the 5 and the power of 2, put it on the bottom and the 1 on top. So what that means is my 1 now goes on top. My 5 to the power of 2 is on the bottom. I get rid of the negative by flipping the fraction. Okay, that's how I turn it into a positive fraction. And really what this is going to equal is 1 over 25. 5 squared is 25. Now I'm going to prove this for you. So once again, let's say we had 5 to the power of 1 over 5 to the power of 3. Now I'm going to write this out. That just means 5 times nothing. Or sorry, times 1. We just have number 5. And we have 5, 5, 5, 5, 5. Okay. Now we all know that we could cancel things out, but we're going to go about this the long way. This becomes 5 over 125. I can reduce this fraction. If I divide 5 by 5, I get 1. If I divide 125 by 5, I get 25. Okay? That being said, another way I could have done this is canceled out those two. I would have had 1, and those together would have made 25. I would have had 1 over 25, the exact same answers we had before. Okay. Now I'm going to show you the way we do this with our rules that we had before. So this is a division question where the bases are the same. So all I have to do is subtract the exponents. 1 subtract 3 is equal to 5 negative 2. And now that we know that how to turn a whole number and flip a fraction, we know that this is going to be really 5 over 1. If I need to make it positive, I'm going to flip the fraction. So 1 over 5 squared, 1 over 25. Okay? Okay, we're going to go through example 1. We'll do it very quickly. It shouldn't take too long. 1a. 4 to the negative 1. What is 4 as a fraction? 4 over 1. I need to make this positive. What do I do? Flip the fraction, so it becomes 4. So 1 over 4 to the 1. And what is 4 to the power of 1? So our original answer, 4 to the power of negative 1, is actually equal to a quarter, 1 over 4. Guys okay with that? B. 8 to the power of 0, what's the answer? 1. That's all there is to it. C. 2 over 3 to the negative 2. How do I turn this fraction positive? Yeah. I do the reciprocal of the fraction. So this becomes 3 over 2 squared. So I should have addressed this earlier. You could have written this like this and then flipped the fraction. I should have written this in. What is 1 to the power of 1? So if I had written this to the, like that, I would have flipped it, and this whole thing would have been to the power of 1. What is 1 quarter to the power of 1? 1 quarter. Doesn't change anything. The reason I didn't write on top is because that number was 1. Okay? We were dealing with 1s at that time. Now that we have different numbers, it looks a little different. So we've now got rid of our negative. Now I need to multiply this. This is actually 3 over 2 times 3 over 2. Anyone know what that equals? 9 over 4. Okay? I double the base. If it was to the power of 3, I'd triple the base. Just multiply it by itself that many times. That was D. Let's do C. Negative 2 to the power of negative 3. Think of this as a fraction in brackets. I flip the fraction, so it becomes 1 over negative 2 to to the power of 3. When I rewrite that, 1 over negative 2 times 1 over negative 2 times 1 over negative 2. 1 times 1 times 1 is 1. Negative 8. 1 over negative 8. And finally, E. 0 to power of negative 2. Let's turn this into a fraction. Is there any need to? What is 0 times 0 times 0 times 0? It's going to be 0. That's when the base is 0. We know it's just going to be 0 or at 0, okay? Even if we wrote it as a fraction, 0 over 1, we flipped it, comes 1 over 0 squared. It becomes 1 over 0. If you type this into your calculator, you actually get an error. You can't divide anything by 0. Your calculator will say error on it, okay? We're just going to have nothing. There's no value to that. Undefined, you can say. I'm going to get you guys, right now, I want to work in your blue notebooks, page 319, numbers 1 to 4, okay? So just work on those right now. We'll do a word problem question after. I'm going to give you about 10 minutes to work on this.